Page 128. We're going to take a look at two problems here, numbers 26 and 27. And the directions are the same. Directions say, after finding the least squares regression line for a set of data, the graph of the residuals looks like the graph on the right. Is the original data set linear? Explain in words why or why not. So let's talk first of all about what residuals are. So let's say we graph a set of data. You've got some points here, and you plot a line that goes through those points. Yikes, it's kind of messy. But what the residuals are, it's the vertical distance those points are from the best fitting line. So in theory, this line's going to go right through those points, right? Meaning some of those points will be above the line, some will be below. And if they're just kind of randomly scattered above and below, it means the data is linear. If the points, like if your first points are all below the line, then above the line, then below the line, that means your data is not linear. We shouldn't be plotting a line here. Okay, so in general, I'm going to get this out of here. In general, if your residuals show a pattern, it means your original data is not linear. If your residuals show no pattern, it means your original data probably is linear. So let's take a look at our residuals over here. No real pattern. Some are above the line, some are below the line, kind of goes back and forth. So since there's no pattern, that tells us that the original data is probably linear. Okay, let's look at 27. Take a look here. Now we've got a definite pattern. We've got some points below the line, then above, then below again. So we've got kind of this up and down pattern. If we see an up and down pattern, either in like an N shape or a U shape, that means our original data is probably not linear. So since we have a pattern here, that tells us that the original data is not linear or nonlinear. Meaning instead of putting a line through our data, we should probably put something else, like some kind of curve through our data.